Assalamu alaikum students. Let's recap normal distribution, right? First of all, the normal distribution is basically a discontinuous distribution, right? So it's used for any variable where the variables are continuous, right? So it's a continuous distribution. Again, that it has some parameters as we already know that basic elements to solve the questions, right? So the basic parameters for normal distribution are mu and variance. So if in any question mu and variance are given, you can easily solve the question, right? Solve the question means if the further they're asking you to find a particular value of x, then you can solve it if you have mu and sigma square. Sigma square means the variance and mu means mean, right? So it also have a formula that is known as PDF, but that is quite complicated and we hardly use it. So we prefer to use the Z table. Z table is a standard normal table which is standard normal table which helps us to find out the probability or the particular x value without using the PDF, means the formula for continuous distribution, right? So in easy word, what you need to know, what you need to remember, that you must know how to find the value through standard normal table, right? So you must know how to read the table, that is most important. Only one key point you need to memorize, that this table always tells you the value from minus and infinity to a certain value. So this you will learn as I will do few questions with you. And the other important thing you need to know to solve normal distribution question is this formula, z is equals to x minus mu upon sigma. That is not the PDF of continuous distribution. That is a formula which converts the x value into the z value, into the standard normal value, right? So once the x value is converted to the z, then I can easily check it through the normal table, right? So this is the main thing which you need to remember and need to know to solve any particular question of normal distribution. But I have taken here such questions where, or you can say a bit difficult question, where you need to find out mu and variance. So I think this is the ultimate maximum highest difficult question could be asked in our examination, right? So let's I have picked over here three questions. So do go through and look all the three questions very carefully, and I'm very sure that it can help you in any kind of examination. The first one is that the random variable x is distributed normally with mu and variance. What is the value of mu, what is the value of variance? So far it is not given. Let's read further. Okay, so the mu is sigma is given. So sigma is given 25. That means the variance is already given, because we know that the relation between standard deviation and variance is the under root thing, right? So okay, for the formula I need the standard deviation, so that's quite fine. Standard deviation is given to me, that what value is over here, that is 25. Find the mu. So mu is not given, rest all is given over here. Let's start solving it. Whenever there's a question of z normal distribution table, first thing always do is make or sketch the distribution, this, that helps you to understand and solve the question quickly. There we know the properties of normal distribution, that it always has a bell shape. Bell shape means it's a symmetrical. At the center, the value can be expressed in the terms of x as well as in the terms of z. In the terms of x, mu always stands at the center. This is the property of normal distribution, that mean, median, mode, everything falls at the same point, right? But the another important property is that in the Z language, you just think that these are the two different languages having the same meaning, right? In the Z language, the value of mu is always 0. In X, the mu is some value depending on the question, but in the terms of Z, it's always 0, right? Because whenever we write like this for the normal distribution, the same goes. I can write like this, or I can say that any variables following normal distribution with the parameter mu and variance, or similar thing, I can say that the x variable follows the standard normal having the mean mu 0 and variance 1 is the same thing. But you do not right now, to solve any question, you do not need to go in its detail. You just need to remember that this formula you have to use in every step, and the sketching is must. Without sketching you cannot solve the question. You can, but then you have to do everything mentally, so it's much better if you do this sketching. Now the x less than 27.5, this is the value of x, so, and less than 27.5 is what, 0.3085. Now since it's a bell shape, we know that the half of the area is, it's the whole area is 1, so the whole area is 1, so this half is 0.5 and this half is 0.5. Now whenever these values are given, you have to use your common sense to identify where you are going to plug in the x value. If for example I assume that x is somewhere on the right side of the mu over here, right? So if x is here, then all the left less than means left side region should be equal to 0.3085. Now use your common sense. If the whole is zero point 0.5, this is anything, maybe 0.1, 0.2, 0.3, whatever. But when I sum up them, minus infinity to this value, when I sum them up, is it going to be equal to 0.3? No, it's going to be more than 0.5. So definitely x is somewhere over here, which is 27.5. Only then I can justify that the left hand side area is 0.3085, because 0.3085 is less than 0.5. I know that from this end till here, all region, right, all region is zero point 0.5. So this particular area is definitely equal to 0.3085. So this is in the what language, in x language, and I don't know what it will be in z language. So the first task I need to do is to find out the same z value for this x. This x has an area less than 0.3085, and I have to find the same z value which has the same area 0.3085. Now for that I need to go and look into the z table. 0.3085, for 0.3085, I need to scroll. This is the area 0.3085, so obviously area is, this part is the area, the inner part is the area, and this is a z value. I need to pick the z value for 0.3085. So I will check where is 0.3085, or I will find the value which is very near to 0.3085. So 0.30, okay, coming down 0.2, 0.3, 0.3085, 0.30854. So I think this is a perfect value. Z, for z minus 0.5, and this first column is 0, right? So minus 0.50. So I got the value that is minus 0.50. So I have x and I have z for the same position. Once I have this, I can go to this formula. I can go to this formula and plug in over here z value, which is minus 0.50 is equals to x is 27.5 minus mu, I don't know mu, upon sigma. Upon sigma is 25. So remember, in this formula we have four things: z, x, mu and sigma. Out of four things, if I put any three values, I can get the fourth value. Now just do the cross multiplication, the same old mathematics, and then you can find the value of mu. So just solve it, and when I solve, I got the answer mu is equals to 40, right? So this is the, I think, most easiest question, where you just need to find out mu. In the similar way, they can ask you to find out mu and sigma both. So if they ask you to find out mu and sigma both, then what you will do, definitely you need to find out estimate mu and estimate sigma standard deviation. So then that means two unknowns. For two unknowns you must have to solve the two simultaneous equations. Let's make the two simultaneous equation. As I said earlier, whenever you have a question, first thing you have to do is do the sketching. Without that, do not move further, otherwise you cannot solve it. Okay, now let's read the question and pick up the important point from here. The masses of the boxes of apples are normally distributed such that 20% of them are greater than 5.08. Okay, so I just write it in the numerical form that 20% are greater than this value. 20% means I'm talking about zero point 0.2, right? And next is written that 15% are greater than 5.62. So 5.62 is 15%, then that means 15% means 0.15. Again, as I said, kid, to put these values of x, you have to use the common sense. I know that if I start putting these x values somewhere on the left side, then the whole right hand side region I am claiming as zero point 0.2 or 0.15. Both are wrong, because I know half is 0.5, half is 0.5. So I must put these values somewhere on the right side of the mu 0, so that if this position is, let's say, for 5.08 and I'm calling it x1, then this whole area will be equal to zero point 0.2, right? And if I am I and I'm saying that 5.62, for greater than 5.62 it's 0.15, so I need lesser area than 0.2, so I must put x over here, the second value of x, which is 5.62, and claim that this region is 0.15. Got it? Because the greater part, it's written here, is greater part in the question. So since it's greater part written, this is greater, that's why I have picked up the right side value. If lesser written, then I would have picked up the left side value. Okay, so now what I'm going to do to make the thing easy, if the thing seems to be complicated, I will separate them out, but this is not important step. It's up to you how you are catching. If you can do it in the one diagram, fine, otherwise you can separate it. For this is for x1 is 5.08 and I want the z1 for that, which I don't know, and this region I know is 0.2. And similarly here is x2, which is 5.62. I want z2 for that, and this is 0.15. Now when I will look this value in the table, remember I told you the table always tells me the from minus infinity to the certain value. So for that, what I will do, I will pick up this area, because z value in the table will define for left side area, not the right side. So if this is 0.2 and I told you the total area is 1, so this whole should be equal to 0.8. Similarly, this whole should be equal to 0.85. So now the task is easy. In the table I will find the z value against 0.8 and 0.85. Okay, so let's look at the z table. 0.8 0.8 will be definitely in the with the positive values of z. So for 0.8 I have 0.8. Okay, I can see 0.8 somewhere over here. It's 0.8, 0.802, look over here, 0.8023, 0.7955. So 0.80 is more near to this value. So this is 0.8, 0.8. Let's look at the top of a column, 0.84. Okay, so for this I have 0.84. I'm writing the value over here first. It's 0.84. Now I will check it for 0.85. Okay, similarly when you check it in the table, you will find it against 1.04, right? Go and pick up the nearest value. If it's lying in between the two, then pick up the nearest value. So I have z1 and z2. Once you have z1 and z2, then you go and do it simultaneously. Then the question is easy. I know that z is equals to x minus mu upon sigma. So when z is 0.84, then x is 5.08 minus mu upon sigma, and on the other side, when z is 1.04, then x is 5.62 minus mu upon sigma. Once I have these two equation, now again the same old work, that is solving the things simultaneously. Just do the cross multiplication. I will do these two things separately, and at the end I will combine the equation and solve it. So 0.84 sigma is equals to 5.08 minus mu. Let's make mu the subject. So mu is equals to 5.08. I have taken mu to the left side, and this whole thing to the right side is minus 0.84 sigma. Okay, this is my one equation. Same I will do it over here. So that turns to mu is equals to 5.62 minus 1.04 sigma. So now I have two equations, mu equals to this, mu equals to this. Both are equal to mu. Can I write them simultaneously, like 1.08 minus 0.84 sigma will be equal to 5.62 minus 1.04 sigma. Now take sigmas to the same side and numbers to the same side, and that will give me answer minus 0.54 is equals to sigmas to the same side, so minus 0.2 sigma. Now I need to solve for sigma. Minus 0.2 will be divided by this, so let's divide it. So minus 0.54 upon minus 0.2 equals to sigma. So from here I got sigma as 2.7. Once you have sigma, now mu is easy to find. Which equation you like, whatever you like, just plug in the sigma value over here. So 5.62 minus 1.04 multiply with 2.7, that will give you mu. So when I put it in the calculator, I got the answer 2.812. Alright, so this is how you can solve for mu and sigma together. That is an important question that's most of the time being asked in the exam. And similar question I have picked up over here, which you can pause the video and do the question with me and check are you getting the same answer or not. Alright, so same strategy I'm going to apply over here, but now I will do it a bit quickly. So it's like metal rods are produced by machine, have lengths normally distributed. The word normally distributed comes, so the first thing I will do is draw the sketch before moving ahead. And I know that in the center I can write in both the language x and z. X has some value of mu, it can be any numerical number, but for z I know this number is definitely 0. So I'm just putting these two over here. Right now 2% of the rods are rejected as being too short. Okay, so something is very short. Short is obviously shorter value will come to the left side. So how much is rejected? 2%. 2% means 0.02, and it is for being too short. I'm writing S for short. And 5% are rejected as being too long. So let's say this is for too long. This is a too long probability, which is 5%, and 5% means 0.05. So now again the same case come. Now it will be easy for me to solve it, given that the least and greatest acceptable value is 6.32 and 7.52 respectively. So least is, so x value for smaller, the x value is 6.32 given, and for longest the x value is 7.52 given. Z value for this I don't know, z value for this I don't know, right? So this is x1 say, and this is x2. All right, so now we are on the same page what we did earlier in question number 2. So again I will find the z value through the table, but see here right now it's already the left hand side region is given 0.02. So I will just look this value in the table. 0.02, it's somewhere on the top. 0.0, 0.00, 0.01, 0.02. Okay, twos are here, in this line. 0.0218, 0.02. Okay, yeah, this number is close to 0.2, is 0.205. Okay, minus 0.205. So I will go here and write that z value is minus 0.2 sorry, minus 2.05. that is the z value. And similarly for this z, now remember, do I will I look 0.05 in the table, or should I look from here to here is 0.95 in the table? It should be 0.95. Check 0.95 in the table, because table always tells you from minus infinity to any particular point. So here I have z2 value, which is 1.64. Now we are on the same page. I will do it simultaneously. So let me do the steps very quickly simultaneously. It's minus 2.05 is equals to x minus mu upon sigma. This is one equation, and the other equation is 1.64 minus is equals to z is equals to x is 7.52 minus mu upon sigma. Again same thing, do cross multiplication, solve it simultaneously as I have solved earlier. So sigma you will get as 0.3252, and mu is equals to 6.986. Do check the answer by solving it yourself. Maybe there are 2-3 decimal place difference. That is quite fine, because all the values are rounded up, so it's all right. Look at the b part. B part is if 10 rods are chosen at the random from a batch produced by a machine, find the probability that exactly 3 means x equals to 3 of them are rejected. So see how they connected the normal question with the binomial, because it's a total n number of trials. How many rods are there? 10 are here, x is 3, are being rejected for too long. So you already have seen that the rods are rejected. That was the probability of being rejected. So what is the probability of being rejected? That was 5%, remember? So that is 0.05. So if p is 0.05, q will be 0.95. Now it's easy. What was the binomial formula? ncx px qn minus x. So n is 10 over here, 10c 3, and for rejected it's 0.05 to the power 3, and 0.95 to the power 10 minus 3. Just put the whole thing in the calculator and you will get the answer 0.0105. That's your final answer for if the, out of 10, 3 rods are rejected for being too long. I hope the concept is clear. Just revise it and you will understand it.